you want something terse. You don't want something verbose because it's just one line, right? So the REPL is good. You get to throw away your code. It's not about like maintenance or anything. It's just about the result. And that's part of exploratory programming.
Welcome to another episode of ArrayCast. I'm your host, Connor, and today we have a super exciting guest to interview. But before we do that, we're going to go around and do brief introductions. I'll throw it to Bob, then we'll go to Adam, and then we'll come back to me.
I'm Bob Terrio. I am a J enthusiast, and I'm working on the J Wiki, and I'm enjoying my time with J.
Adám Brudzewsky, full-time APL programmer, though I don't get around to doing so much programming, busy with, wikis and educational materials and so on.
And I'm your host, Connor, non-professional array language and combinator enthusiast at large. I program in C++ day-to-day. And yeah, super excited about our guest today because she is a fellow polyglot, probably even more so than I am. So before we get to introducing her, I think we're going to have one announcement from Bob, one announcement from Adam, and then a short announcement from myself. And then we will hop into introducing our guest.
Just this past weekend, the new J beta dropped, J904. So I think it may be in beta for a while. These often are. Often they end up maturing around December and then the new version comes out. That's what happened with 903. The neat thing about 904 is it introduces concurrency. And so there are all sorts of things you can do now or are going to be attempted to do. It's right in the midst of development. If you are interested in concurrency, this is a great time to get involved because they literally are building it and getting ideas from people and trying to put things together. So any expertise is welcome in the J environment.
And I have good news. So for years, very valuable, interesting APL papers and other array programming papers have been stuck behind the Association for Computing Machinery, ACM's paywall. And they've just decided to open up everything from the first 50 years of ACM history to be completely free. So that basically means all those interesting papers are now available. Many of them are linked from, say, the APL Wiki.
Yeah, that's super exciting because most of the papers that I read, they date all the way back into the 20s, 30s, 40s. Or actually, that might not even be ACM then. So, well, who knows? Because that's definitely more than 50 years ago. But definitely a lot of the J and APL papers are going to be available now if they weren't already available on the J software site. So, yeah, we'll link to that in the show notes. And my short announcement is, I think I announced this maybe 2 or 3 episodes ago. There's a new sort of online editor or interactive REPL for BQM. And there's been some huge enhancements to it. And it's just getting better and better and better. Previously, I think when you were defining functions and then calling that on arrays, it would say, oh, it wouldn't display the result because they said side effects were involved. But now it shows the results. It's like halfway in between an editor and a REPL, and they've got light and dark mode. They've got different fonts. They've got different VMs. It's like crazy awesome. So once again, I think Andre Pop is the individual that's primarily working on that. So huge kudos to him. And we'll have a link in the show notes. And also we'll probably link the tryAPL for APL and the J playground, I think is what they're calling it as well. Because, yeah, all really easy ways to sort of step into the array language world.
And not to jump in on your announcement, but the J Playground actually now has plot and view mat as well. So you can actually plot things on the screen. So it's growing as well really quick. So all these things are kind of taking off. It's really neat.
Yeah, in the future, no one is even going to be developing on their desktop. If you look at what GitHub and Microsoft are doing, you just hit, Shift dot, and then you're in like VS Code online mode. So yeah, pretty exciting stuff. But with all those announcements and introductions out of the way, let's get to the most important one of them all. Today we have a special guest, Vanessa McHale. Hope I'm pronouncing that correctly. And she is a polyglot programmer and also a former math major. She has developed and has a ton of different projects on her website. I think primarily you develop in Haskell, and you can correct me if I'm wrong, but also Futhark, J, ATS, Idris, a language I've never even heard of called Edgison or Egason. I'm sure we've upset, maybe 1 or 2 of our listeners that's actually heard of it before. And so I'll stop with the introduction there and maybe throw it over to you and tell us a bit more about yourself and how you, got to the point where you're developing and not just a plethora of languages, but also, J and Idris, these are a lot less mainstream than, a lot of people have experience in Python and Java. So yeah, super curious to hear your story and how you ended up in these different, sort of, I won't say esoteric languages, but just less mainstream languages for sure.
I've been doing, I guess, Haskell for 5 years professionally. So I was initially attracted to it because it was sort of interesting and obscure. I think the Haskell world is, I don't know if it's like cooling off, but it's definitely gone more mainstream recently. So I've been, if Haskell is your job language, then you've got to do something else for your, I guess, hobby language. Been doing some ATS, some Fuzark, J. I think those are the big ones. Fuzark is also an array language. It's very much in the like ML Haskell side of things. ATS is like very hard to explain. It's very difficult, sort of like C and ML crossover. Academic language, definitely a lot of fun. Got into J, I guess. There was like some Chris Double presentation about APL. I'd initially, I guess, brushed it off, but going back, just seeing, I guess, how different it is. Used it for some data science stuff. I mean, I guess I'm excited about the sort of like exploratory programming there. I think a little bit better than Python and definitely cooler. And I mean, there's a lot of good material on it, honestly, which is big help.
So do you mind telling us how like, because I actually didn't really, I think maybe the first time I ever heard about Haskell was about 2 or 3 years into my career after graduating, and I think someone mentioned at work that I might like the Arch Linux operating flavor because you need to know a little bit of Haskell to install it. That was the first time I'd ever heard it mentioned, and then it wasn't until like another 3 or 4 years later that I'd sort of I went outside the world of C++, and then someone said, oh, you should maybe pick up like a functional language like Haskell. And then I said, oh, I think I've heard of that before. Like, so, but it sounds like you came across it pretty early. Did that come from studying or school or?
I don't know. I think I've stumbled upon it online. I guess this would have been like 2015 or so. So I was in the middle of school, and part of what got me into it was the Accelerate library, which is like incidentally an array library targeting the GPU. So there's a lot of just like cool functional and compilers stuff written in Haskell. And I didn't quite realize how big it would get. I think among the choices like Haskell versus OCaml, it ends up being that Haskell ends up like, I don't know if it's like the default functional programming choice, which is a little strange and shocking, but lots of good concurrency stuff, lots of like good compiler stuff you can learn from there. So I've been, working at it for 5 years.
And when you first stumbled across it, did you have, because if you've listened to any functional programming podcasts or the rhetoric around, a lot of people they discover Haskell and then they say, oh, this is not for me, it's way too difficult. What was your experience like first coming to Haskell? And especially like Accelerate is I'm not sure, I actually haven't played around with it, but it was like a research library that I actually think some folks at NVIDIA worked at. So that's some advanced stuff that you were dabbling in. Like, it's not like you were doing the Hello World. You went straight for the fun stuff.
I think the Accelerate library had like all the hard stuff. I guess part of what is cool with Haskell is like being able to do not the hard stuff, but like you could use Accelerate, you could write the sum of an array, and you can write it on your GPU. And I mean, I didn't know how to write CUDA or anything at the time. I still don't, but you can encapsulate a whole bunch of that. I mean, in terms of the difficulty, I think, I don't know, I just stuck with it. I do like difficult, challenging things. I think over time I've appreciated that like the Haskell way is almost always the correct way. I didn't have the perspective initially, but I don't know. I guess it just partly good luck. It did work out. So.
And would you say the same thing about OCaml? It sounds like you have a little bit of experience with OCaml as well, or is it something specifically about Haskell and the laziness that you prefer?
I don't know about OCaml. I mean, my impression is that OCaml is good. And then like OCaml is strict and Haskell is lazy and Haskell is very different. I think day-to-day people don't always use laziness that much, but it ends up being, I mean, it's definitely very subtle.
And so it sounds like, and up until that point when you had discovered Haskell, what programming languages had you had familiarity with? Like, was it just the standard stuff, or was Haskell literally the first language you stumbled onto?
I think it was like from school, there was like TI Basic, and then they learned like Scheme, Java, trying to think what else. I think Python, just like for scientific computing. So Haskell was like, okay, well, I guess this is like better than Python. And initially it was quite irritating, but over time, I appreciated it.
And where did you go? So after, that's been, I guess, since 2015, since you first stumbled on it. At what point did you started, is it once you got the taste for Haskell, then you started exploring what other kind of weird, less mainstream languages are there? And, what was your journey from there to Futhark and J and ATS and all these other languages?
From Haskell to, I guess, Idris was like sort of a natural step. It's like if you like obscure things, this is the even more obscure one. And Futhark is written in Haskell. The compiler is written in Haskell. Idris, the compiler, was written in Haskell. So that was a pretty like natural branching off point, I guess. Futhark, I think, it has more capability than like Accelerate, for instance. It just generates faster code. So that was sort of crazy to see, but a good thing for sure.
So what can you tell us about? Because I know I've spoken with Troels Henriksen, the individual that created the language and is the main contributor. If you look at the GitHub insights, for sure. But I actually haven't programmed any Futhark code. Is it very similar to Haskell, or what's the differences between the Futhark language and Haskell?
I guess from Haskell, it's like Futhark is a proper OCaml. So like the way you have abstraction is like modules and instantiating modules. I'd say it's very complementary to J. So like Futhark runs on the GPU, and then J is like this very good exploratory language. I don't think Futhark is just not as strong when it comes to like exploratory programming. There's various things that make it like, it has to be delicate, it has to be planned out. But then on the other hand, J doesn't run on the GPU, it runs on the CPU. So it's very different. A lot of the time they use like the same combinators or methods, right? Like there's basically one way to sum an array, right? If you have in J, it's like you have the dyad and the adverb, right? And you combine them. In Futhark, there's like a reduce combinator of some sort, and you reduce with the addition function. So you end up doing a lot of the same things, which I think is pretty interesting, just in terms of like the folds, the maps. I guess in J, that's like dyadic reductions using adverbs, or the what is it? It's the quote conjunction, I think.
Bob's our resident expert on J. So,
oh yeah.
Well, yeah.
So the quote conjunction, you're talking about the gerund, I'm trying to think of evoke. Is that the one?
Oh, I think so, yeah.
Yeah, so what it does is it takes a series of gerunds, and then you can use evoke to activate them and make them run like they're verbs. One of the things I think is kind of interesting, though, is Futhark is compiled, right?
Mm-hmm. Yeah.
And J is interpreted. Mm-hmm. I'm guessing that J gets to call a compiled language that works. That's not a big deal. But are there issues between those two boundaries?
I think the big thing, from what I understand, was like J and array implementations is like you could do reference counting. So there's like a different implementation if it's like an in-place modification versus like copying. But you write the same function and then the interpreter does the work. I think with compiled languages, I don't think there's anything like that, at least not now. So I think that's definitely one of the things that makes J and other things easier. It's nice to like be able to run reasonably fast without, I guess, putting in so much effort every time.
Yeah, that's something that Henry's done a lot of work on. Is we usually refer to it as special code. So, if you know those little idioms, those combinations, things run very smooth and very quickly and use much less space because he's doing all that behind the scenes.
Yes.
And that's what makes this whole concurrency thing kind of interesting, because suddenly he's delving into, I guess, potentially using GPUs. And actually, in the last months, Jay has brought in ArrayFire.
Right.
So you can actually run ArrayFire from Jay. So that's sort of, they're all nudging into the GPU, and it's interesting to see how it all works.
I'm interested to hear more too, because I've really tried to find an articulation for why it is, what is it about J and other array languages that, like you said, it leads to a more sort of exploratory feel / like the flexibility of it. Is it, sometimes I think it's the dynamic typing, and then I'm like, well, I don't even really use the dynamic typing. And other times it's like, well, it's the REPL. And I was like, well, there's other languages like Schemes and Racket and Lisps. They have REPLs, and it doesn't have the same. And then some of them are statically typed. Most array languages are, or did I already said that? Yeah, dynamic typing. And I'm not sure. Do you have thoughts on what is it that makes, J versus Futhark or Haskell, what lends it to being more of an exploratory kind of playful experience?
I mean, I think honestly, one of the things is like just it's shorter to type things. Like you can write a one-liner and it does basically what you want. I think having a plotting library is good. Haskell doesn't. Futhark, like the way it does polymorphism, in the OCaml way, it's a little heavier. So like you need to instantiate it for each type. If you're in Haskell or J, it's like you can type in 1 + 2, you can type in 1.0 + 2.0, and it'll work either way. So I don't know if the dynamic types are all of it. I do think like the I don't know if it's the rank conjunction, like the double quotes with a number. I think that's a pretty big one that like Haskell doesn't have, Futhark doesn't have. I don't think anyone's gotten around to adding that. I don't know what the like technical PLT theory is, but it does seem pretty different. Maybe rank has something to do with it.
What does Futhark use instead of rank? If you're trying to, because you're instantiating on the GPU, you're not worrying about the shape of the matrix.
So I mean, like there's the map in functional programming, so that's very familiar in Haskell, for instance, and that's the equivalent. So you can also like map twice or map 3 times, but like saying map 3 times is a little like less fluent than just using the double quotes and the 3, right? So I think that might be part of it.
It's interesting because I never really think that rank polymorphism, which is the fancy term for the fact that you can just add scalars and vectors and matrices when you're dealing with scalar operations. Like I've never thought that was really like a selling feature of the language. It's like it always gets mentioned in the top 5 things of like, oh, what is it about array languages? They have rank polymorphism. And then I just remember one day I was switching from APL to Haskell, and I had tried to do some sort of equality operation, which of course you just, whatever equals whatever in APL and it'll work. And then I realized, like, why isn't this working? And I had forgotten that I needed to explicitly map. And it becomes something that, like, you don't think is that nice. But, like, once you really get used to it, it's very irritating, especially if you have to, like you said, you have to map a map or map a map. Like, that's, like, it is such a, not like a cognitive barrier, but just, it's very simple when you look at the, APL or J code. That 1 equals 1, 2, 3, 4, 5, and it returns you a Boolean array. Like, okay, that makes sense. Why should I have to, the implicit mapping via rank polymorphism is really, really nice. And it's interesting too that you mentioned the first thing is that the tercity, because I never want to say that because the reaction you always get is like, what did my co-host of one of my other podcasts, he said, what did parentheses ever do to you? And or he said one time too, like, what do you have against like characters? Like it's 2 characters less, like what's the big deal? But it like extremely impacts, being able to commute an operation with like reflex in J or commute in APL. That goes from like one operation, a minus, to or 1 character, which is a minus, to 2 characters. Whereas in Haskell, the spelling of that is, FLIP, flip, space, parentheses around the minus. And then if you're going to pass that to a mapping operation, there's another set of parentheses that you have to add. And it sounds silly to say that, like, going from, 1 or 2 characters to 10, like, oh, that's too much. It ruins the flexibility of the language. But I do think, like,
Yeah.
It has an impact that's, like, non-trivial. And anyways, I just found it interesting. That was, like, the first thing that you said. And I always want to say that, but there's a part of me that says, no, like, you shouldn't say that, Connor, because then people it's easy for them to make fun of you.
But it's not the ones. It's kind of when you show the example of, like, using one character to commute the arguments versus flip and parentheses and so on. But it's the constant doing more and more and more. The important part of your algorithm might be a few characters, and it just drowns in noise, in map, parentheses, and dots, noise everywhere. I lose track of what I'm doing when I try to write JavaScript. I have 2 lists, and I just want to add the elements from one list to the elements of the corresponding element of the other list. I can't even use a map for that, right? Because it only map over one array. So I have to do a map with an iterator and use that to index into the other array. And nasty globals everywhere. I definitely think that has value. It's not the brevity as such, it's the lack of noise.
Well, and I'm a really undisciplined programmer. So for me, it's that brevity means if something's not working the way I want, I go in and change one character and now it is, or now it's working in a different way. And I'm not having to change a whole list of things. I'm just changing one thing. Okay, now I know what I got. And it just speeds up the process that much more. And for my style, which is, as I said, very undisciplined, I'm just literally playing. If I had a more verbose language, it would be really hard for me to have the same kind of feedback loop that's so quick.
Then there's the fun of it, of course, making lots of commits, each of which is a single character changed, and then with long comments as to what all the features just had added. Right?
I mean, I think it's like the whole, like, APL way works together, and it's like, I don't know if it's like a cult thing or just, like, off in its own direction, but, like, you're in a REPL, you don't want to, like, type more than, like, 100 characters per line. If your function definition is, like, 200 characters, suddenly that's a problem. So I think that's part of it. Or, like, depending on the tool, right? Like, regular expressions are terse, but if you're searching for something in Bash, you want something terse. You don't want something verbose because it's just one line, right? So I think it's like the REPL is good. You get to throw away your code. It's not about, like, maintenance or anything. It's just about, like, you get the result, and that's part of exploratory programming. And I think, I don't know, there are other styles, right? Like, you wouldn't want your memory allocator to be, like, a throwaway sort of code, but that doesn't mean that, like, the way C programmers work is what you need to do for, like, scientific programming. I don't know. I also think, I guess, like, with numbers, it's easier to check yourself in, like, sophisticated ways, right? Like, if you have, like, okay, I'm going to compute the cumulative distribution function for, like, a normal distribution, for instance, right? And then you have your function and you test your output, and you know what it's supposed to be, right? Like, you see, okay, that's 0.84. That's basically exactly right. So if it gives me the exact right answer on several different numbers, it probably means I, like, wrote my procedure right, because there's no way for this math to be this correct. Like, so I don't know. I think working with numbers in general is probably easier in any language, but with J, it works out.
Yeah, it's interesting too that you mentioned, like, when you're in a Bash terminal or your terminal of choice, and you're building up some expression, like, how many times do people do the cat of the dollar of a list of files and then pipe it to word count to get how many word counts are unique? Like, there's actually an interesting analog there. Like, everyone's fine with ls and, like, tr for replace and cat for opening files, like, and all these short expressions so that you can build something up that's very terse but does a lot, because, like, it is empowering. empowering when you're in a terminal to be able to very quickly, get some information. And I've actually thought that like APL would be like an amazing fit because so many times now, like I usually have a ride sort of editor open in the background, and I'll use it for like little anytime I need to do like a calculator or a calculator plus sort of calculation. Like literally the other day, I had a string of the characters that are possible to be used in a binary message in Smalltalk, which is very random. But like it had a bunch of unnecessary dollar signs and spaces. So I just took that as a string and did without, which I think that has an equivalent in J. And then you can basically just on the right put space and dollar sign, and very quickly it removed everything. And I was just like, it's basically like when you open up the calculator on whatever your operating system of choice, but it's a calculator plus because you can do things with lists and matrices. And it's interesting. I like never thought of that really when you had just said, oh, like people are okay doing things in a terminal. Is like no one has a problem with that. Well, I guess maybe there's some people that like to use a mouse, but
it must be like familiarity, I guess. I don't know. I think some of the J stuff, like forks, is like a little stranger, but I think being terse in general is definitely like a good thing. And
yeah,
there are a lot of built-ins you rely on, I guess. Like if you want to like compute the 7-day sliding average of some vector, like you can do that super easy in J. I think there's basically a built-in for it. It's like dyadic infix or something.
That's exactly what it is. Yeah.
Yeah.
Yep.
Yeah. There's definitely certain things, and maybe that's an interesting question to ask. Like for your different projects, or when you're just playing around, is there times when you're reaching for, seeing as you have such a toolbox of languages, from Haskell to Futhark to Idris to J to ATS to the ones I haven't even heard of? Like, how do you go about choosing which language you're reaching for when you're trying to solve a problem?
I guess I use J or something like it for most like data processing. Like if I have a CSV, then I want to use a vector language often. Haskell's my default just because I know the most. But I actually was like working on this like a speculative like text filtering program, and it's in many ways different from like J or an APL, but I really did like it has a little language. You can type in expressions, and I did take inspiration from like terse symbols and characters, right? So like there's a deduplication, there's like a length operator. So I think that sort of style has stayed with me. I don't know. Sometimes I end up thinking like, I wish I could make another language, which a lot of work and might cause future problems. But that's where I'm at recently, I think.
So what's in your ideal language?
I don't think I have like an ideal. I think Haskell's still pretty comfortable. I don't know if I'd be capable of like making something else to move away from that. But like ATS has like linear types. It's good for manipulating memory. I think a big one like would just be whether it's a text filtering like APL on the command line where you like pipe in something and pipe out APL output. I don't know. That would be a nice. I don't know if it would be APL or like J or some derivative, but I think that would be a nice thing. A lot of people would. Well, people who are already enthusiastic would perhaps want it. I don't know.
Yeah, the idea of an array language. And for the one for the command line, with the idea that would be a little bit more like, I don't want to say first class support for text processing, but sort of, yeah.
I think somebody made such a thing. Yeah, Applette. I think was that the one. Yeah. It describes itself as being like a specialized utility along the lines of awk and sed, but for array processing rather than text-to-string processing.
Cool.
And so it uses ASCII glyphs in order to have like super low overhead, and you can just type it on the command line to filter things when you aren't wrapping for text, but you want to extract some data from something on the command line.
That would actually be, like an interesting sort of toy project is basically like a K dialect, but specifically for the command line where every symbol is a single character. And although you can already get a lot done, like I actually don't know Set and Awk very well, and I've heard Awk is actually a really really nice language. But yeah, that'd be an interesting project.
Not sure. I mean, I think for the moment, I still have things where I'm like, I wish this were better. Start working on it. There are times when I'm like working in Haskell and I'm like, these dependent types are not as good as Idris. So that's just, I don't know, boring, frustrating. But opportunities to like do more, I don't know. I think ATS is like also a big, it's more academic research than like hobbyist. That's like definitely a big gap. Is like there's nothing to like manipulate pointers and arrays of bytes. Yeah, I don't know.
It's interesting too that you seem to have you're both operating intellectually or like mentally at like the very high level of like J, but then also at the very low level of C languages and memory allocation and memory management. Where does that come from? Because usually, like I think people like to choose. Like I accidentally ended up at the C++ level, but I think mentally I prefer being at the APL level where there's some sort of GC or automatic reference counting or there's all the different flavors. I don't really need to think about it. And my ideal is like if I can just get some GPU language that is just blazingly fast and like a little bit of allocation is not a big deal, then who cares, right? But like so, yeah. You seem to think at both levels. Did that just come from your studies or courses or?
I'm trying to think. I think I do, on some level, prefer the higher level, but I guess there's two things, right? There's like the K does something with memory mapping, which I think is very impressive, and they end up getting much better like performance than the R people with their data tables. And then I think there's like a trend in programming languages about thinking about like rather than thinking about languages, thinking about like what are the implementation algorithms that let you do XYZ. And I think interestingly, there's a lot of stuff on like compiler backends, which is not as well researched, right? Like people will talk about type systems and type systems and type systems, but there's not as much, or maybe this just is older, right? About like explaining like how register allocation, changes the programmer experience, things like that, right? Or like, I guess with K, how memory mapping makes the database so fast. It's like faster than any other CPU database. And yet, for some reason, people are not always imitating it.
Have you got any feelings, Vanessa, about why these languages aren't quite as popular? I think I read something you'd written a number of years ago, something to the effect that language, well-constructed and effective languages are not necessarily the most popular ones, and quite often aren't. Why do you think that is?
I think with J, comparing it to Haskell, I think one of the big things is the CFFI. And I think that's the same with like Lisp and Smalltalk, which get brought up as examples. It's like, it doesn't matter if you're a good language. The thing that C does, which it does better than any other language, is it, shuffles around bytes. And because it shuffles around bytes, you can call it from any language. You can, export your functions with the C ABI. And I think that's like a very difficult thing. It's not just like exporting your functions in the C way, but it's like if you want to use J inside Haskell, it's just difficult. Or if you want to use like J within Python, how do you like bring to Python like forks and rank? And like you have to be able to export your ideas in some useful way. And I think, like K found its niche, right? And now they're just like, make a bunch of money. They have some happy customers. But I think, yeah, like when you compare it to C or like Haskell has good FFI, a lot of like weird, sophisticated stuff they have to do. But yeah, I think the like lack of communication between languages is a big one, just because people want to do that.
Yeah, I think that's one of the huge reasons why Python is so popular, because its FFI story is so good. Like, I've always been curious, is that like Python's older than Java. Like people think of Python as this sort of, oh, it's younger language. Like Python is not a young language, and it had, similar to Haskell actually, it has a similar story in that it had like created right around 1990 and had this kind of slow burn and got more and more popular as time went on. Sort of like Haskell did it in spite of, like, they didn't, their whole thing, didn't Simon Peyton Jones say, like, you know, we don't want to be successful because then we got to support people or something like that.
Oh, this is like a famous one. It's not like avoid success at all cost. It's avoid success at all costs, right? So it's like less cute, I think, but that's okay. Like, the idea is to not, like, you know, I mean, Java is like popular, but they grew a lot. You know, Haskell grew more slowly, and they like made more principled decisions. You know, it's better to get foundational decisions right than to like build your community by just like putting something out there, which I think did work out pretty well for Haskell.
Yeah, it's definitely true. There's definitely been some languages that I can think of a couple off the top of my head that it's not clear that decision destroyed the success of the language, but definitely it hindered companies' ability. Like, the language that I'm thinking that comes to mind is the D language. Like, early on, it couldn't make up its mind between shipping with a GC or not shipping with a GC. So, like, I don't even know the full story. I just know at one point it had one, and then at one point it didn't have one. And that led to, like, there being two different versions of the standard library, one that was sort of backed by GC stuff and that one that wasn't. And it was just like toggling on that decision. There were definitely some companies that used it and were super, super happy, but others that are trying to upgrade from C++, if they hear like, oh, they haven't made their mind up about GC or no GC, that's going to be a big thing. But yeah, Python, Haskell, they both sort of slowly got popular, and I've always sort of been curious on, like, you know, I can see why Haskell got popular, because like you said, they were really taking their time, getting the important decisions right. But Python, I think Python has like a really great ecosystem, but like that ecosystem wasn't always there. Which is why I've sort of, you know, I've heard some people say, oh, it's just the FFI. Like, it's one of the best languages for doing that. I'm not sure if you have thoughts on why Python is so much more successful than other languages out there.
I think I read something about like NumPy. NumPy is like the API that scientists use. And I'm not sure, like, one, I think they're just like going to be stuck in their ways for like at least a few decades. But I think NumPy was inspired by J, right? So that makes sense. But then at a certain point, it's like J has like NumPy support. I think presumably K does too. Like, every single bit of scientific code is in NumPy. Sometimes it'll be like in pandas too. So it's just, I think partly momentum. I think NumPy is like not bad for the CPU, but yeah, like at this point, NumPy is like the API rather than like C almost for scientific computing.
Yeah, and I think momentum is a huge thing. Like, you know, I work for NVIDIA, and a part of our strategy right now, like the team that I work for is on a team that basically builds a GPU accelerated version of Pandas. And there's another team at NVIDIA that is also working on basically a GPU accelerated version of NumPy or NumPy. I'm not sure how it's pronounced. Like, I would love to, like, let's just start from scratch and do something like shiny, but it's a lot easier to convince you know, corporate management that, like, hey, there's already X million people using this API or this library. If we go do this with it, you know, we can get them, you know, buying our hardware. That's a way easier sell than like, let's start from scratch and convince people that like our way is better, or like not even from scratch, that like this language we have from the 90s or the 60s, you know, whichever one you want, that like this is the direction we should go in, because if people are already using something, it's a way easier sell, which is just, I guess, the way that corporate America works. Or I shouldn't say America, it's the way the world works. Yeah.
It's the way the world works, really, because I mean, it's just anybody doing any kind of performance. If you do it to a small audience, it's going to take a while to catch on. If you hit a mainstream audience, you're going to make a big bang. And the money is with the mainstream audience. It's with the fat part of the curve.
So I wonder if we should, because I mentioned at the top of the episode that you have sort of a plethora of projects, and I think you've alluded to a couple of them. I think one of them was this. I'm not sure if it was one of the projects you have listed, but the speculative was it string processing or string filtering? Do you maybe want to talk about whichever are your favorite projects? Because it looks like you have a ton of really, really cool ones that like I would encourage. We'll definitely link this. It's I think your website is VM or vmchale.com. And then if you go to the portfolio, there's a huge section on programming that has a lot of it's open source because you just have it listed on GitHub. So you have stuff in J, Futhark. Do you maybe want to talk us through a couple of your favorite ones and maybe some that our listeners might find interesting?
So I guess I've got, well, the two recent, I guess, bigger ones. One is Jacinda, which is like this text processing language, partly inspired by APL and such, which trying to be terse with syntax. Try to think. The Futhark, I've got a nice little image processing library. So I think a bunch of that is working, and that's pretty fun. It's just like a showing that you can just like literally just run your code on a GPU, and it's faster than SciPy, which I don't know. I guess speaks to Python and like where things could go. I have like a stack-based language. I don't know if that's another weird one. I don't know if you've ever used like Joy or Factor, but this one is called Kemp, and it's well, it's a toy compiler. I don't think the language is great, but the whole world of what is it, like stack-based languages is pretty cool. It's another area where like there's not necessarily lexical scoping. I think J, you sometimes want lexical scoping, but sometimes you can do with forks. So this is like I don't think it's a smaller world. Well, I guess stack-based came a little bit after, but also like APL or J has developed sort of in its own way. So
Interesting. Another term for the stack-based is concatenative languages, and I think I first heard of concatenative languages when listening to Functional Geekery back in 2018. And yeah, so Forth was like the OG stack-based language, and then Factor, Joy. You've mentioned that Mirth was so. First of all, I had no idea. So we have I guess not necessarily. Who else maybe was a program language creator that we've had on in the past? Because we've had implementers, but not necessarily creators. I think from our past.
Marshall.
Oh yeah. What am I talking about? I don't have a full memorized list in my head, but that's super awesome that you've created a programming language. So yeah, tell us. And I've watched maybe 3 or 4 sort of online talks. One about Forth, one about Factor. So I know a little bit, and I've maybe typed a couple lines of code in one or the other. But yeah, tell us a little bit more, maybe about concatenative languages in general, and also Kemp. This is super cool.
So Kemp, I think it ends up being a very good exercise for like writing compilers. I've actually, I don't know, maybe like teachers will want to use some such example. I don't know if you're familiar with like some types. I guess that's like one of the things that definitely good. Not always easy to get right with array languages, but I think J and APL don't have that. There's a really like weird way that like some types and pattern matching work in concatenative languages, which I think is pretty interesting. I don't think I'm the first to find that, but it's pretty cool. Trying to think. Yeah, basically there's like no binding or names aside from like calling other functions. So everything is sort of the same. It's sort of funny. You're like pushing things onto the stack, popping them off, which is definitely familiar to, I guess, like Forth programmers.
Some people might have used reverse Polish notation on HP calculators, same kind of thing.
Yeah, I'm looking at the manual right now, and it's similar. I find it interesting that and I've actually we have to talk to Marshall about this because I'm curious because I know he looked into concatenative languages at one point as well, and his was actually the first array language that in the documentation did I ever find the word combinator from combinatory logic. Like he actually refers to a set of, I guess he doesn't call them adverbs, he calls them modifiers, but what are adverbs in J and APL, he actually referred to them as combinators. And it's interesting because in your docs it mentions dupe and swap, which they don't exactly map to, but they are functionally equivalent to sort of the reflex in J and passive, or I can never remember because they have such odd names. Reflex and passive are like reflexive. One of them does, commute and self or whatever APL and BQN call them are much understandable names from my point of view. But it's interesting that the overlap in that kind of like function application manipulation in both concatenative languages and array languages, and also Haskell. Haskell has not very good uniform support. I actually have that in a paper that I'm trying to get published, is that they have all these combinators, but they're scattered across different libraries like control.applicative and control.monad. And one of them's in one called data.composition.
Have you ever looked at Jelly? Has anybody here ever looked at Jelly?
Mm-hmm.
I mean, not the food item, the programming language.
I only know of this because Marshall mentioned it to me on that email that you were also on when I said, "Oh, Marshall's created the two most recent array languages," and Marshall said, "Oh, that's not true. Jelly and Jelly is if you think J and APL, if you think J and APL are weird, well, you haven't heard of Jelly yet."
Also, if you think APL and J are terse, you haven't seen Jelly. But Jelly is interesting because it's very much inspired by J, and in fact in some things, like a classic thing, + is for summation, just like any good APL will respect for itself. But it doesn't have the ambivalence of primitives. So every function is either monadic or dyadic or nidic. So then it behaves like an array, and that means every function definition is tacit. So it's all using a type of trains, not the APLJ triple trains forks. But the interesting thing is it very much feels like it's concatenative, stack-based. Many people even get that wrong idea about it because it doesn't use any parentheses. You can just string. Think of it as like the K-style tacit function. So it's just lots of tops. Just apply a function, apply a function, apply a function. But because the functions are fixed valence, then it can consume arguments. If you have a dyadic function, it must consume one more argument. And if there's a monadic function, it consumes one argument. In that sense, it's kind of like the stack-based thing, but it really isn't. And it does use higher order functions to combine things. It's really fascinating. We could get Dennis, the author of it, to come visit, but
we should note though, for the listener that is not staring at the GitHub necessarily docs page, is that although that all sounds very, very cool, the character set that is used for this language is like capital A with a dot over it, capital A with a dot below it, capital A with a dot. I don't even know, but like the deltas, the visual deltas between these characters are in many cases very subtle. And like I've seen the Hello World, and it looks like, you tried to print something and like there was a printer error and it just ended up printing some noise.
Okay, to be fair, that's a golfed one, meaning as short as possible. Jelly has a built-in string compression and decompression, so it doesn't hello world doesn't spill out hello world. It just looks up in the dictionary the word for whichever number is the word hello. And
Why would you? Why would? Because isn't that at the top of the documentation? Like it's what it's what's shown as the hello world.
but
They should show.
it's a golfing language. It's intended to be as short as possible. But to be fair, the character set is all typable on a US international layout. So it's actually easier to get to typing it properly than say APL is or BQN is. It doesn't require a specialized keyboard. Every computer has access to, and every operating system platform has access to the US international layout. So it does have some merit in that. It tries to use mnemonic names for things. It's not so bad. Sometimes I can see Jellycode and understand a little bit.
And I think you have to be careful about saying that a language looks like line noise, because a lot of people claim that's what our languages look like.
Who are we to speak? Well, especially Jay.
Yeah, but I love it.
Just held down shift and was leaning on the number row on the keyboard.
That's true. The Array Language podcast, calling other language. Wow, I mean, this is that's true. I should take that back. We should. We're all under the same umbrella. Let's. If we're being honest with ourselves,
you can write readable anything and unreadable anything. I think, or within some limits. Just look at Arthur Whitney's C code. Is that readable?
Mm-hmm. I think he just writes like that. I don't think it's like intentionally obfuscated. Yeah.
He doesn't try to obfuscate. He tries to not scroll.
What conversation was I in the other day when the J Incunabulum came up? And I think it was the Denver C++ meetup, either 1 or 2 Thursdays ago. And I shared my screen and showed it. And I started off by being like, I initially thought that this was absolute like line noise. But if you actually... Because I think someone made a joke about using macros in C and then just like redefining everything to one letter, and I was like, "Well, hold my beer. This is actually a thing." And I went from like sort of joking about it to being like, also though, if you like quickly, if you know that V1 and V2 are just monadic and dyadic verbs, and that do is a loop, you can actually scroll down and see the definition of iota, and like, it's not immediately obvious what it's doing, but it's not like also as impenetrable as you'd think. Like if you just take 2 seconds to like familiarize yourself with like the 4 macros at the top, or 4 of the whatever 10 are at the top, and it's very easy to say that something looks hard to read when you have zero familiarity with it. And then as soon as you take a little bit of time, it's like, actually, this isn't as bad as one might think. If you think of it as maybe a different language, then, it's clearly not classical C. It's a kind of DSL that uses a bunch of macros. And once you know those macros, it still looks a bit odd. But, I mean...
But, Connie, you can't say that, right? It's perfectly normal C. The fact that the world at large doesn't write C like that, nobody altered the language to be able to write it like that. It's just C. It's just valid C.
I mean, when I say classical, yeah. Vanessa just sort of went like this with her hand. It's, people don't, it's like 90+% of folks are writing sort of in a certain style. And I don't think relying on macros to create a DSL. Like I think I agree, totally valid way to write C. I think when my quote unquote classical is just that's not how most folks. In fact, like in C++, macros, they get used in cases where like there's no other option. But like a part of the evolution of C++ has been to try and add things that basically make the need for macros disappear. And so like the goal is at some point C++ 26 or 29 is hopefully going to get reflection, and then that should... I mean, there's some people that theorize that it'll never be possible to get rid of the macro because it is just so powerful, to a fault.
But you can say this in any language, or at least language that's under development. For many, many years, it was perfectly normal in APL to create character vectors that were APL expressions and then compress them with a condition, so 1 or 0, and then execute them. So that's a kind of if statement. Conditionally execute this code that you have built up or not. in today, when at least common popular APLs have control structures and some operators to choose what to do, then that's looked down upon. But you can't come and say it's invalid APL. It's
It's not normal APL.
no, it's not. It was normal APL, right? And who is to dictate what's the right way of doing things? It's not. Some people might be uncomfortable with it, but then again, I can recognize the programming styles in APL of my colleagues. For somebody who doesn't know APL, they look at it and it's all garble, characters they don't know how to pronounce. But I can make sense of some of it because I do APL all the time, and some of that I see I don't like. It's perfectly valid APL. I just don't like it.
Well, this is kind of a philosophical, and I'm interested maybe to get Vanessa's thoughts because you're primarily a Haskell programmer. It's this the question of, what makes a programming language a functional language? Because some languages classically, Haskell, OCaml, but then there's certain languages like you could mention Rust or Swift that you can code functionally in them, and there's a lot of people that do, and I think there's even like a functional Swift conference. But a lot of people, if you call that language functional, they say, "Oh no, it's not a like." Do you have thoughts on like what is it that makes a language fall into like one paradigm or another, or sort of by extension, like what is classical or non-classical?
I think APL is like its own sort of like alt functional. Like they're definitely functional languages. They have adverbs where you would say like higher order functions. And that was like independently invented. Maybe it was invented first. I think the difference with like Haskell or APL is like, at least in J, you can like use indexing, right? So like you can grade an array and you can use that result to index into the array, and then you have like a sorted array. I don't think anyone who wasn't an array programmer would like think about it like that. It's a difficult thing too. Like, I mean, part of like what makes APL viable or what makes J viable is like the reference counting so that you can modify in place and all of these like efficiency things. So like if you write recursive code in certain cases with like standard NML, then it gets compiled to a bunch of jumps the same way, like a for loop would in another language because of register targeting. So it ends up being like very difficult. And I don't think anyone's familiar with like compiler internals, but like when you have Haskell, it's compiled with GHC and like a certain functional style becomes viable. If you do that in like Swift or Rust, I don't know if that happens, but I'm also like not familiar. Like you need to know the compiler internals. So I think like, immutable data structures and functional programming, it's just like it's a super hard to get it perfectly on the nose.
I'm going to jump in and ask the Stephen Taylor question. And Stephen's under the weather today. He just let us know that he wasn't going to be part of the panel. But my question is, how does the array programming languages change the way you think about the way you structure your programming?
So I went into this with like Chris Double's, I guess like a slides presentation. I think I'd written off dynamic typed languages. Like, okay, well, that's like sort of wrong and outdated. And then I went to see it and I was like, okay, like this actually works approximately fine. And like there's certain things that are missing, but like you can totally program in this. I think exploratory programming just doesn't get enough like attention. I think programmers are all like in their world, and I think scientists and other people are in another one. Trying to think. I think there's just like a lot of like different wisdom, and it ends up working together, right? Like other people like to like name their stuff verbosely, and like you split it out into 3 definitions, and in J it's just like one line, and it's all symbols. And all of those decisions, like if you had decided to just like write everything together in Haskell, that's a bad decision. Or if you like decide to like split things out, I guess that's a good decision. And then in J, it works differently. right? Like everything together, and you sort of have a sensible way to program, even though like all of your individual habits are basically totally opposed to the mainstream, right? So you're writing terse code, like you don't bother to like factor it out, you just write it in line and throw it away, I guess.
That reminds me of the Aaron Shu talk. I'm not sure if you've seen it, where he has sort of like a list of 8 things that are sort of in mainstream versus like in APL, and like one of them is libraries versus idioms. That in like in mainstream languages, you have libraries for all these little string utilities, et cetera, et cetera. But he said it's more common in APL that like you just have some little 3 or 4 character expression that does that, and like do you need to name that split, because split is more characters than like the spelling out of the expression. So it just becomes like a kind of better bread and butter thing that you start to learn these expressions that are spellable in fewer characters than it would actually take to name the thing. Which is, like you said, it's very antithetical to the what we learn in school or what we learn on the day job, is that, oh, it's all about refactoring and a level of indirection. And his whole thing is like, no indirection. Like you can just write it in line, and it'll, if you learn to read it, it can be more.
No, I mean, I think there's like opportunity. Like you have Git for C programmers, and then it's like in J world, it's like, do you even need like version control? You can just like memorize it and then type it in every single time, which seems just like totally absurd and backwards, but it's actually not even that bad. And I think the way the J interpreter does like idioms is pretty cool, like telling you this is fast explicitly, right? So then you have like underlying implementation, which you know is probably going to be sensible, which I think is better than like, I don't know, in Haskell world, they have their own stuff, but like being able to read the manual and say like, if you write your code like this, it will be efficient. I think that's something more languages should do, because, just not part of their system, I guess.
Yeah, it sounds, even when you just said like memorize it and rewrite it, like my first thought, my gut reaction was like, well, like that's really like you have to rewrite your program from scratch each time. But then I just remembered that
it's like 10 letters. Yeah.
Yeah. Well, even when it's more, Aaron Shu gave a talk at the most recent functional conf where it's called like 3 sort of DSLs, or his code. It's basically him showing the 3 different ways that he implemented his code defunds compiler using sort of 3 different techniques. And he's actually rewritten each one of those techniques like, a couple different times. So he's up there basically saying, because my compiler, it's not a trivial amount of stuff, but it's also not like, it's not an overwhelming, 100,000 or 200,000 line code base. I have the ability to play around and re-implement it a couple different ways. And that exactly lines up with what you just said. Like you don't need a version control system for something that you can fit on, half a screen or one line.
And I think it's like I don't know, like more respectful to the user in some ways. Like other programming languages, you're trying to be like really hard against errors, handle errors like explicitly. And then I think in J APL, it's more like about transparency, right? Like if you write a mean function to like you have like some verbs to say the 7-day sliding mean, and it has some implementation, and like if your user calls it wrong, then like maybe that's on them, and like you can just see the like 4 or 5 letters anyways. So I don't know, it's a different approach, I think, less like condescending maybe.
It's interesting because I think both in J and APL, and people can correct me if I'm wrong, like the code that's shipped in the different libraries, at least I know this is the case for Dialog APL, the whatever defunds, like you can, all that code you can look at, like you can read, which is similar to like the Smalltalk system, where you can step in and look at sort of the code, where a lot of the times, depending on which language you're debugging through, that's definitely not possible. So
Wait,
yeah,
really?
It's another interesting point that like when you can look at the
Wow.
Yeah.
I didn't realize. I just
Yeah, a lot of times when you're dispatching to some, binary, like you don't necessarily have the source with that. So
because of that, right? But that's more an artifact of it being compiled, right? And that you can't just step into it. Like if you had something that's entirely interpreted, any website, you stop it in the middle, you inspect the JavaScript, you can trace through it unless it's been obfuscated. But
Yeah, sometimes the problem is that with a lot of Python code, it is interpreted, but then it's like the pandas and NumPy
it's calling
stuff.
to
It's
C eventually.
basically, it's exactly. So it is quote unquote interpreted, but the backend is some compiled C code or some compiled C++ code. So you can debug down to a certain point, but then usually the point you actually want to get to, it's like, oh, now we
Okay,
don't
but
have access to
then we
that.
always have that at some point, right? I work with a version of Dialog APL that's going to come out, and there are sometimes bugs in that has gone into a pre-release version, and at some point I get to like, this primitive doesn't seem to behave properly. I give it some sample arguments. I can't step further into it. Right? At this point, it's kind of calls into a C library, which is the interpreter itself. So you're always hitting that.
But I do think, like, I was looking at like SciPy code in Python, and they tend to have like, just, I guess it's like a different attitude, right? It's like I mean, they comment it heavily. They like check to make sure that like if you pass in a zero length vector, they won't compute the average of that. They'll tell you that like it has zero length. And the thing is, like, one, Python's more verbose because it has like for loops. But then just like having the if check, it makes the whole thing so much denser and harder to follow. I think, if you have in J, you don't even need an average function, but if you did, and someone passed in a zero length array, then it's like, okay, well, that's on you, right? And it ends up, I think, working better, right? Because then you can actually like see the code that you're using. Python, not so much, just because it's like verbose, it's full of checks, it's full of extensive comments. And I think, I don't know, maybe that's all right too, but it's definitely different.
I can see the difference there. Like when you're doing all this for fun APL, then yeah, you just, or exploratory, you don't care about checking things. You know what it is you're getting in. And then sometimes I write these utility functions that have to be like totally hardened. Whatever you throw at them, they must behave nicely and not leave the user in the middle of my code. And a large amount of my code then ends up being just checks and error messages and things like that, telling the user this isn't right, this isn't right. And the actual code that does something is just these tiny little short lines in between all the checks and all the error messages.
So I will say we're getting, I think, probably a little bit close to time, but I definitely want to ask a last question, and maybe we'll ask another if Bob and Adam have one. But I'm wondering if you have any advice for maybe folks that are still in school or younger folks, because like I said sort of at the beginning, it's I don't think people have done enough what you have managed to very, very successfully do, which is sort of explore different paradigms and different languages, and not just the mainstream Java and what, like you said, Java, Python, and Scheme. And I guess Scheme is kind of out there nowadays. It was less so, back a couple decades ago when they were teaching SICP everywhere. But do you have like advice for sort of younger students on like how to I don't know, successfully explore the languages, and like what is it that enabled you to sort of navigate all these different sort of less mainstream and build up, get to the point where you're building a concatenative language and in Haskell and all that stuff?
I mean, Haskell's in like a funny place now, sort of like calcifying, solidifying. But I think having like confidence in good ideas is like a big one. Right? Like Haskell, I mean, at the time I was doing it, there were just fewer jobs, and now there are, a reasonable number of jobs. People are using OCaml all over the place. Like Bloomberg uses OCaml, Facebook uses OCaml. So I think like having some confidence in good stuff and taste. And I mean, it does take like a few years to pan out, but maybe looking, years ahead is a good idea.
So then I guess the question is, how do you develop that? I mean, because everyone here is going to agree that you've got great taste in programming languages. But yeah, how does one cultivate that sense of taste? Because I definitely, I did not have that early on. I was just like, I don't know, semicolons and braces seems good to me.
Yeah, I mean, I don't know. I haven't done C++. I've used C. I guess part of it was like exposure, just like doing Python, doing Haskell, and deciding like, maybe Haskell is doing this like the sensible way. Not 100% sure. I guess like digging at foundations can work. I'm not sure like how I wasn't like super aware of what was good in Haskell at the beginning, but it was a weird one. It was like a little bit of hype, but looking for like academic and difficult stuff can be fun. So that's good too.
Yeah, so it sounds like the advice is to just explore, and when you think you see a good idea, don't necessarily write it off just because it's in a language that isn't a top 10 on whatever your TIOB or what. There's like 16 different programming language rankings, and depending on which one you look at, there's somewhat a bit of variety, but Python and JavaScript are always close to the top. So, any last questions from Bob and Adam? All right. Well, thank you so much, Vanessa, for taking your time to hang out with us today. This was a blast. I can't speak for Bob and Adam, but I always love nerding out on sort of different languages, and I feel like we're definitely going to be having you back at some point in the future, because at the rate that you are pumping out projects, I won't be surprised if some new programming language in the future is normally like, oh, what's this? And then we're going to see your name attached to it, because it sounds like you're constantly exploring stuff and have already been thinking about a potentially, ideal language that may or may not come to fruition.
Thanks for having me. It's been a lot of fun. Good to meet you.
All right. Thanks so much for coming on. And with that, we'll say happy array programming.
Happy array programming.